All right, this learning objective is factoring quadratics. All right, and I can put a few stars around this learning objective because it's probably the most important learning objective we've done so far this year in terms of success in future math classes. All right, right now, this is an entire learning objective by itself, just being able to factor quadratics. All right, but when you get to classes like calculus, being able to factor a quadratic is like 1/10 or 1/20th of an entire problem. So being able to do this effectively and quickly is going to really help you in the future in your math classes, as well as a couple units that we do in the future. All right, so first of all, I used a new word that I haven't really used before, all right, and that's quadratic. All right, so quadratic equations look like this. All right, the most important thing is they have this x squared in them. And we'll actually spend 2 units just dissecting quadratics and everything we can learn about them. But right now, just know that your quadratics kind of have these 3 terms, and the most important there being this x squared. All right, so previously, when we were factoring, we learned about factoring out the GCF. All right, but what's the problem if we try to factor this expression using the GCF? And hopefully you see that if you try to use the GCF, there's no common factor. There's no number that divides 2, 5, and 3, -5 and -3. And there's no variable in the last part, so there's no common variable that I can pull out from everything either. So there's no greatest common factor, so we can't factor it that way. We want to see if we can still break this down into kind of component parts. And what we're going to do is basically reverse FOIL. All right, we're going to reverse the foiling process, all right, so that we can turn this quadratic that has no common factors into this, all right, 2x plus 1 times x minus 3. And it seems really weird to students at first, if this is your first time learning this, that this kind of one term with an x squared breaks down into these 2 individual terms. But we do what we've learned before and FOIL this out. 2x squared minus 6x plus x minus 3. Combining those middle terms gets us the same thing that we started with. All right, so this is just like factoring numbers, are breaking it down into the things that multiply to give you your answer. But we're breaking this one quadratic into its 2 terms that would FOIL out to give us that expression. All right, so we're reversing the FOIL process. And when we go through and actually do the process for factoring, you'll kind of see the FOIL process, but in reverse. All right, so here are the steps. All right, it's not going to make much sense when it's written in words, but I kind of want you to have these in your notes so that you have them in words and you can compare each example we do to the steps. So the first thing we do is find this special pair of numbers. All right, so it's a special pair of numbers that are going to add to give b. All right, b is the number that's right next to the x. And at the same time, the same pair of numbers has to multiply to give AC. So A is the number in front of x squared. C is the number by itself. All right, so we're going to multiply those 2 things together. All right, so we want to find a pair of numbers that adds to B and multiplies to AC. All right. Then what we're going to do, we have this special pair of numbers. We're going to split up the BX term into 2 separate terms. And it's kind of the weird step that a lot of students forget to do. But we'll see what this looks like in an example. All right, once we split this up into 2 terms, then we'll have 4 separate terms, so we can factor as 2 groups of 2, because 4 can be broken down into 2 groups of 2. And then we unfoil to get our final answer. So again, it doesn't make much sense right now in words, so let's do an example. All right, so here, we're going to factor 2x squared minus 5x minus 3. All right, b is -5. So that's our b value. And then AC, if we multiply A is 2, C is -3, so that's going to be -6. All right, so we need to find 2 numbers that multiply to -6 and add to give -5. So we're going to add to give this number and multiply to give this number. And what are those numbers going to be? Again, it'll take a little bit of trial and error first. I always like to start with the multiplying things because there's less options to multiply than to add. And the numbers that are going to multiply to -6 and add to -5 are -6 and +1. So those are our pair of numbers to start with. All right, and that just practicing that takes a little bit of effort, but the more you do it, the quicker you'll be able to go. Now our next step said we split up this middle term into two terms. We're going to have 2x squared. That doesn't change. But now we're going to use these numbers to our advantage. Instead of minus 5x, we're going to have minus 6x plus 1x. Again, you don't normally have to write the 1, but I'll just write it. So these two numbers from here are going there. And it seems like a weird thing to do. We're making the problem more complicated because we went from these 3 terms to these 4 terms. But the nice thing with 4 terms is that you can break them up into 2 groups of 2. So I have this first group of 2 and the second group of 2. And inside those groups of 2, now we can do factoring out the greatest common factor. So the greatest common factor from 2x squared minus 6x is going to be 2x. And that is going to be an x minus 3. All right, there's nothing in common between x minus 3, so I can just say like I factor out a 1, and that leaves behind x minus 3. And now I unfoil this. I have these two x minus 3s that I can say is part of the answer. And what's left over if I get rid of the x minus 3s? All right, if I've gotten rid of the x minus 3s, you can see I have a 2x plus 1. All right, so this is the factored form of that quadratic at the top. Again, for these, always check your answer by going back and re-foiling. So I foil this out, I get 2x squared minus 3x times 2 is minus 6, plus 1 is negative 5. Negative 3 times 1 is negative 3. All right, so you can always check to make sure you factored correctly by foiling out your answer. And nothing's going to change in the process, but again, it's just the more you see, the more you do, the more it becomes ingrained, and you can do it in other problems and other contexts. So we're just going to keep doing examples. B is negative 5. AC is 12 times negative 2. Again, it's important to remember your negatives is negative 24. All right, so how can we multiply to get negative 24 and add to get negative 5? Again, this is our first big challenge, is finding these two numbers that work. All right, it's a little trial and error. So 24, the ways you can multiply, give 24, or 24 and 1, 2 and 12, 3 and 8, 4 and 6, 5 doesn't work, and then we're back to 6. So those are the 4 ways you can multiply to give 24. And the pair that's going to work is negative 8 and positive 3. And just always double check. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. All right, so those are our pair of numbers. And now I can start the process of splitting this up. All right, I do 2 groups of 2. The first group I can factor out a, 4 divides both those, and an x. It's going to have 3x minus 2. Second one, second group of 2, nothing in common, so I just pull out a 1. Pulling out a 1 doesn't do anything. And now I get my final answer, 3x minus 2, 3x minus 2 times 4x plus 1. All right, so that is our final answer. There's one thing you might be wondering is, how do I know to write the negative 8 first and then 3? The answer is, it doesn't matter. So let's just quickly do this one in the opposite order. All right, we're 2 groups of 2. The first group of 2, I factor out a 3x. Is behind a 4x plus 1. The second group of 2, they're both negative, so I'm actually going to factor out a negative 2 to make that 4x plus 1. And 3x minus 2. That's 4x minus 4x plus 1. All right, so the steps will be a little bit different if you write these two numbers in opposite orders, but you still get down to the same answer at the end. All right, the process is the same. I'm just doing this factoring algorithm. I think I do one more example before it's one for your own. All right, but B is negative 4. AC, all right, it doesn't look like there's an A. If there's ever not a number in front of x squared, it's a 1. All right, so AC is negative 12. All right, so looking for numbers that multiply to negative 12, add the negative 4, it's going to be negative 6 and positive 2. It looks like most of the examples I've chosen so far have one negative and one positive, but it's possible for them both to be positive or they're both to be negative. All right, just kind of look through and make sure you fit both categories. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. Now I can rewrite this. Again, the order doesn't matter. When you split up that term, it just might be a little bit different. At the first pair, I can factor out an x. The second pair, I can factor out a 2. And I see my final answer, x minus 6 times x plus 2. All right, so no different than we did before. Just know if there's not a number written, then it's a 1. And so here's a one for you to try on your own. And here's the answer I got. So we're looking for numbers that add to 5 and multiply to negative 24. This is kind of the opposite of one of the problems we had before. Now 8's positive, negative 3 is negative. All right, split up this term into 2 terms. Do your 2 groups of 2. And you see we have 3x plus 4 times 2x minus 1. Again, you don't even need me to tell you if you have the right answer, because you can always FOIL your answer down here and make sure you get back to what you started with. All right, so I'm going to do a couple more examples in the video. All right, but there's some people who might already be comfortable with this, ready to go practice or do the skill check. Other people, this might be the very first time you're learning this. You might want to see some more examples, so it's up to you at this point. I'm going to do 3 more examples, all right, and you decide what you want to do at this point in the video. All right, so here's another example. All right, again, same thing. We're just practicing the same thing over and over again in this one. So our b value, there's no number here, which means our value is 1, because it's multiplication. And then our AC, I'm going to have to use a calculator for this one. 6 times 35 is 210. Except for it should be negative 210 because we have a negative sign there. All right, so we need 2 numbers that multiply to negative 210 and add to 1. All right, so this is how I would kind of go through generally and figure out this pair. So this number is pretty big, because I can't just do it in my head. So the first thing I do is I always know there's 210 and 1. All right, that's not going to work because they are 2 separate. All right, so then I can do 210 divided by 2, and I see 105 and 2. All right, that's definitely not going to work. So then I do 210 divided by 3. So I see 70 and 3 is a pair. That's also not going to work. Divided by 4. That's a decimal. If I divide 210 by 4, it's a decimal, so that doesn't work. 210 and 5 is 42. 42 and 5. 6 works. 35 and 6. 7 works. 30 and 7. And there's a lot of factors here. 8. 8 doesn't work. 9 doesn't work. 21 and 10 works. I'm just kind of going through all the numbers and seeing if it gives me a decimal or a whole number. 12 doesn't work. 13 doesn't work. 14. 15. And the next number would be 15. And once I get to the other side of the column, I know I'm done because I've already kind of done all those numbers. So these are all the different ways I can multiply to give 210. And I'm looking for ones that are going to add to give 1. All right, so if they're adding to give 1 and multiplying to give a negative, one of the numbers has to be negative, and it's going to be the bigger one's negative. So this column should be negative, and this one's positive. And then my answer is going to be down here, negative 15 and positive 14. All right, so it might take you a little bit of time, but you can kind of go through all the different ways you can multiply to get this number and eventually find the pair that's going to work. So we're going to have 6x squared minus 15x plus 14x minus 35. All right, the first group of 2 looks like I can factor out a 3x, 2x minus 5. The second group of 2 looks like I can factor out a 7. Give me 2x minus 5. Again, you know you've done it right when these 2 are the same. If these 2 aren't the same, you've done something wrong at some point. You'll have to kind of diagnose to see at what point, but you know you've done it right when those are the same, and you get your final answer there. Again, you can always FOIL. Make sure you get back to where you started. All right, here's another one that I'll probably have to use a calculator for, but B is 38. AC is 5 times negative 16. Let's do that. 5 times negative 16 is negative 80. All right, so you can go through and figure out all the ways to multiply to give 80. Wanting to add them to the 38, and actually this one I can kind of see right now is that 80 is 40 times 2. I'm going to make the 40 positive and the 2 negative. Those will multiply to give negative 80 and add to give positive 38. So now I can write this out, 5x squared plus 40x minus 2x minus 16. All right, our two groups of 2. That first group of 2 I can factor out of 5x. Go ahead, x plus 40 divided by 5 is 8. And whenever these terms are both negative, I want to factor the negative out to turn them both positive. I'm going to factor out a negative 2. That'll give me an x plus 8. My final answer, x plus 8 times 5x minus 2. All right, so same process over and over again. This first step is really the one that takes the most effort of kind of going through all the ways you can multiply by numbers to get them to add to the right thing. Once you do that, the algorithm's always the same. Break up this middle number, do two groups of 2, get your final answer. All right, so now try to practice. If you still need help, all right, reach out to me, get some extra help with these problems. Like I said, this is a really important skill. It's not going to go away at any point this year, not going to go away in pre-calc or calculus or any other math class. All right, after algebra 2, you're always going to be expected to know how to factor quadratics, so it's going to come up a lot. We'll always have to repractice, so take the time now, really make sure you have it kind of locked down of what you're doing, and then get ready for the skill check.